Okay, good morning again, everybody. I hope you guys have seen the problem set. So last Friday, as promised, I have uploaded problem set number 2. So though it's hard probably for most of you to work, we don't have any choice. Life will go on, and we just need to keep moving forward. So tuloy yung ating problem set, and the deadline would be, kailan nga yung deadline? Sa Friday, no? Right before midnight. So just a quick recall. Um, ano nga yung mechanics doon? You need to submit, ilan yung pinasubmit ko? 4 or 3? I think I asked you to submit 4 problems, right? 4 problems. So required yung number 1, which is the essay part. Required then yung part 2, the objective part. Though it's tinawag ko siyang objective part, pero like A to C, they are justified true or false. So you need to explain your answer. And then D is computational a bit. E is also computational. So numbers 1 and 2 are required submissions. And then dun sa proving questions, kailangan yung pumili ng dalawa. Pero the deal is dapat isang even numbered problem at saka isang odd numbered problem. So you pick between 3 and 5, and then you pick between 4 and 6. So yun yung deal natin sa problem set. So 4 items. So you still have you need to answer one per day. So para makaabot kayo sa deadline on Friday. Okay? So any questions about the problem set? And actually over the weekend I've been quite busy. I wasn't able to finish the revisions of unit number of our lecture notes for unit number 3, though the corrections that I will post will be very are not that significant, so medyo typo errors lang sila. So I'll just send you an update probably later tonight or tomorrow. So para dun sa corrected unit 3 lecture notes, okay? But just I made some edits to bago ako online, some edits to the lecture notes for unit number 4. So if you downloaded it earlier, please download the latest version. So ito yung version probably that went live around 11:20 this morning or 11:10 this morning. So kindly download it. Yun yung i-discuss natin ngayon. So we are essentially going through, or we will be starting a brand new chapter in the course. So ito yung second to the last course. So ano na nga bang ginawa natin? In the first unit, we talk about the real number system as a complete ordered field. Tapos natingnan natin ano yung significance ng pagiging isang complete ordered field. Actually, basically, the properties of R being a complete ordered field allowed us to develop calculus. Okay, so kaya dun sa pangalawang unit we talk about sequences, which was very instrumental in our development of limits. Okay, so though yung definition natin ng limits and continuity, merong epsilon and delta, but we have seen that there is a very striking sort of equivalence na rin na masasabi between limits of sequences and limits of functions, right? So because there is a characterization, and in fact, some references might have used it as their definition ng pagkakaroon ng limit. Pwede kasing i-define mo yung limit ng isang function not through epsilon delta, but through the equivalence theorem. I think it was theorem 3.8, if I'm not mistaken. Yung sasabihin na limit ng f of x ay equal kay L if and only if yung sequence ng function values ng isang sequence na nagko-converge dun sa limit point x of 0 ay nagko-converge din kay L. So there's a very striking relationship or equivalence to some extent between sequences and functions insofar as limits, the concept of continuity, kahit yung pagiging Cauchy are concerned. So in the last 2 units in the course, we'll be talking about the other 2 main themes in calculus, derivatives and integrals. And dito sa dalawang units na to, konti na lang yung maging adjustments natin. So basically, these 2 units are designed to give us a deeper understanding of the things that you have learned in elementary calculus. For instance, your calculus courses during your freshman year might have been focused more on computing limits, computing derivatives, computing integrals. Ngayon, papalalimin natin yung understanding natin about derivatives and integrals. So I guess the unit on differentiation or derivatives is quite short. If you look at the lecture notes, it's just 10 pages long. So I was hoping to finish half today and half on Friday. Tapos para next week, start na tayo ng unit number 5. And with that, I think we'll be able to have the problem set during the last week of May. Or pwede siguro ang submission ay first day ng finals week, or even hindi, kailangan ko pala ng time mag-check, no? Yeah, siguro posible natin gawin na ang submission ay first day of the finals week at the ayoko muna magsabi ng at the earliest kasi baka maaga naman tayong matapos ng Unit 5, so we can have the problem set earlier para hindi siya sasabay dun sa problem sets nyo sa iba yung courses, okay? So with that in mind, let's start and talk about derivatives. As I've said, this is a relatively short chapter, so we actually only have 2 sections here. The first one we will discuss the definitions of the derivatives and basic properties. Tapos, didiretso na tayo kagad sa main result for derivatives, which is called the mean value theorem, which is something that you have already encountered in Math 36, all right? So ngayon nga lang, mas papalalimin natin yung pagkakaintindi natin sa mga konsepto na ito. Okay, so we'll start off with looking at the definition of the derivative of a function. And if you will compare this to what you have seen in Math 36, hindi na natin mas pinalayo yung itsura ng definition. After all, derivatives are simply limits. They are limits of special quantities, all right? So in definition 4.1, we are assuming a function f that is defined on a set A, a subset A of the set of real numbers. And we say that this function is differentiable at the number A, okay? And note that there is no requirement on the number A except that it is on the domain of the function A. Unlike the concept of the limit, dapat si A ay limit point ng function f. Pero dito, wala tayong requirement ng pagiging limit point. So, although babawi pala siya, no, kasi yung pagiging limit point, ibig sabihin hindi ka kailangan nasa domain. Pero sa derivative ng isang pagde-define ng derivative ng isang function sa isang number, dapat ay define yung function doon sa number na iyon. It is not necessary for it to be a limit point, pero dapat element siya ng domain. And actually, dito pa pala papasok yung kailangan siya ay isang limit point. Actually, kailangan ba siya limit point? Hindi siya necessarily na maging limit point. The only requirement is that there should be a small interval or some open interval. Hold on. Containing A except possibly an A. Okay, so I guess this phrase actually implicitly requires A to be a limit point of the function f, kasi kahit dito sa umpisa sinabi niyo na si A dapat element lamang ng domain, pero the second requirement is that the function f must be defined on some open interval I properly contained in A, and that contains A. So ibig sabihin dapat si A ay nakatira sa isang dapat si function f ay defined sa isang open interval containing the number A, and that makes A limit point of the set A. Kasi nga nandun siya sa interval, pag naroon ka sa isang open interval, magiging limit point ka na kaagad. Alright? So limit point ka ng I, limit point ka na rin ni set A. Then what's the requirement, or how do we find the limit? How do we find the derivative of the function f at the number A? We will just use this definition over here. So basically, this is telling us that f prime of A is equal to the limit of sort of the relative difference between the function value of f at x minus the function value of f at a all over. Actually, there's a problem here. Yeah, this is a number. Actually, this number will give us f prime of x. Tama, no? So dapat tinanggal ko na pala siya doon. Kasi ang gusto ko dito ay f prime of a. Or probably, hold on. Yeah, probably I should delete this one. Ito na lang yung matitira. Gamitin na lang natin yung second part ng definition. Ano? Wait. Okay. Siguro para magamit ko rin yung first part, lagyan ko to ng evaluated at x equals a. Okay. So basically, the first equality here will require us to calculate this. Hold on. Nakakainis, hindi talaga ako makafocus, no? But anyway, tama pala siya. Sorry. So yeah, tama pala yung derivative na yan. So f prime of a is equal to this, to the limit of the relative quotient. So we take the quotient between f of x minus f of a and x minus a, right? So whatever limit you get here, then that would be our value for the derivative of f at the number a. An alternative formula for that is by looking at the increment. So that means we're looking at the relative change between the function value after incrementing on the domain element with respect to the increment. So pag dinagdagan mo si a ng kaunti, ano yung nangyayari dun sa distance between f of a plus h and the original function value with respect to the increment h that was added. Okay? So here h can take a positive or a negative value kasi titingnan lang natin yung limit as h approaches 0. Okay? So if this limit exists, then we say that f prime is f prime of a is the derivative of f at a, and we can also say that f is differentiable at the number a. Now, if f prime exists for all points in a set I or in an interval a, interval I, then we say that f is differentiable on the set I or on the interval I, and we write f is an element of di. So I'm using a script d to denote differentiability. Tapos nasa loob ng script d, ng curly d, yung set kung saan sabi ko differentiable yung isang function. Okay? Now, medyo mabigat yung kailangan ng definition and derivative of a function because here we are requiring the function f to be defined in some open interval. In Math 36, it was no big deal because when we started talking about limits, this part is already in our assumptions, all right? Nire-require na natin kagad bago pa lang siya magkaroon ng limit na si f ay defined sa isang open interval containing the number a. Pero dito ngayon pa lang siya pumasok sa konsepto ng derivative. Why is it important? Because the concept of the derivative, as you might recall from Math 36, is the instantaneous rate of change. So basically, this is measuring how a small change in the input to the function changes, how a small change in the input translate into a change in the function value. So yung tinitingnan natin, maliit na pagbabago sa input, gaano kalaki yung nagiging pagbabago dun sa function value. So if you sketch the graph of a function, okay, and you want to calculate the value of the derivative, say at a number a here, okay, titingnan mo ano yung nangyayari kapag ano yung pagbabago sa function value relative to the change in the x value. So basically, titingnan mo, halimbawa, nabawasan ng kaunti yung aking function value. So naging a minus h ako. So the relative change between the function value at a and the function value at a minus h is basically the slope of the line joining these two guys. Right? So yung slope ng line na to, ito yung tinatawag natin na secant line kasi magpa-pass through siya sa dalawang sa dalawang data points doon sa ating curve, right? Now, the slope of the second line represents the relative change. But if we make a minus h very, very close to a, that means h is a very, very small number. So, ibig sabihin, palapit ng palapit ka rito. So, that's what we call, and if we take the limit as h approaches 0, yun yung tinatawag natin na tangent line. And the slope of the tangent line represents the instantaneous rate of change of the function, right? Now, why is the key na ma-define yung function sa lahat ng numbers sa isang open interval containing the number a? Importante yun kasi you cannot talk about instantaneous rate of change if there would be isolated points between near a. So kung meron mga points na malapit kay a kung saan hindi defined yung function, ibig sabihin hindi magme-make sense yung pagme-measure ng relative change. Kasi nga tinitingnan natin, gusto natin itong point na to ay palapit ng palapit, yung second point ay palapit ng palapit dun sa a, f of a para ma-compute natin yung instantaneous rate of change. Now, if the function will have infinitely many points kung saan hindi siya defined, na dun sa mga point, dun sa infinitely many points close to a, then hindi magme-make sense yung pagka-calculate ng derivative. Kasi kailangan magkaroon siya ng limit as h approaches 0. Okay? So yun yung konsepto ng derivative. At kung sana napansin nyo na wala itong masyadong pinagkaiba dun sa natutunan natin mula sa Math 36. Okay? So just to illustrate how to make use of this definition, tingnan natin yung example 4.1. Example 4.1 gives us this theorem that we learned from basically probably one of the first theorems or derivative formulas that we learned from Math 36. Ito yung power rule. Kung meron kang f of x na equal kay x to the power n, where n is any natural number, okay, then the derivative of that function at the number a, or at any real number, is given by this guy. All right? Now, the derivative of f evaluated at a will be n times a to the power n minus 1 when a is not equal to 0, and it is equal to 0 when a is equal to 0. Now, I was thinking earlier, bakit ko nga ba to pinaghiwalay sa dalawang cases, all right? Kasi alam ko naman na derivative nito, for any x, dapat ay n times x to the power n minus 1, ano? Tapos magpa-plug in lang naman ako ng a, and then this is a polynomial, so this is supposed to be defined everywhere. However, meron pala magiging complication, ano? Kapag ka si n ay equal kay 1, so magkakaroon ka ng, okay pa rin yung derivative na ang derivative ni x to the power n ay nx 1, but when n is equal to 1, so the exponent here will be 0. Tapos ito ay 1. Tapos pag in-apply ko tong formula yung formula dun sa taas, magkakaroon ako ng 0 to the 0. Yun yung in-avoid na case, kaya merong second condition rito, right? Because if you plug in a equals 0 here, and if at the same time n happens to be equal to 1, then magkakaroon ka ng 0 to the 0, which is undefined. Okay? So kaya, alright, so pinaghiwalay ko siya sa dalawang cases. Now, to prove this assertion, madali lang. Gamitin lang natin yung limit definition na nandun sa definition. Okay. So makikita natin, alright, so this is basically how we define f prime. Okay. Tapos gawin ko yung limit ng x to the power n is f of x is x to the power n minus f evaluated at a, so that's going to be a to the n divided by x minus a as x approaches a. And then pagka pinerform niyo yung long division, or if you remember the special product, this quotient simplifies to this. Okay? And then kukunin ko yung limit, ito ay polynomial lang naman, and we know that polynomials are continuous everywhere, so ang limit ay equal sa function value. All right, specific to polynomials and other continuous functions. So you plug in a into this guy. So no problem here. It's going to be a to the n minus 1. This guy will be a to the n minus 2, pero naka-time siya ng a. So kakaroon tayo ng a to the power n minus 1. Ganito rin dito, a squared. Pero ito magiging a to the n minus 3. So we'll be left with a to the n minus 1. Siya yung nandito, and so on. And you will notice that all of these will be a to the power n minus 1. Tapos bibilangin natin ilang a to the power n minus 1 yun nandun sa sum. So this is n minus 2. So 1, 2, 3. Hanggang dito, makakaabot tayo sa n minus 1. Tapos, meron pang isang extra term, yung constant term. So there's a total of n terms in here, right? Kasi may mga x's, meron na kagad tayong n minus 1 of them. Tapos yung constant term, isa yon. So a total of n terms. So, and this is why I restricted the case here that n is a natural number. Para mabilang natin kung ilan nga ba etong mga ito. So there are a total of n such a to the power n minus 1s. Pag inad ko silang lahat, makukuha ko ay n times a to the power n minus 1. And that proves the first case, provided that a is not equal to 0. Okay? Bakit siya mag-work bakit itong expansion na to ay mag-work lang kapag si a ay hindi equal kay 0? Kasi kapag si a ay 0, ito lamang ay magiging x. Work pa rin pala siya, no? X to the power n minus magiging x to the n over x. Actually, yun din yung ginamit na proof dito. Tapos magiging x to the power n minus x to the power n minus 1. Tapos, then this will be a to the power n minus 1. Pero ito yung magiging 0. Okay. Yeah. Isip ko kung ano. Si x to the power n minus 1 ay continuous pa rin naman. Pero kapag ang n ay equal kay 1, ito talaga yung awkward dito. Kasi last time binago ko tong conditions na to. Why am I being uncomfortable writing the limit equal to 0? Polynomial lang naman yung x to the power n minus 1. I am trying to avoid having a 0 to the 0 case, right? Pero kapag kasi si n ay equal kay 1, kapag si n ay hindi equal kay 1, ibig sabihin ito ay automatic 0. Pero pag si n ay equal kay 1, this would be x to the 0. And then bago ako mag-evaluate ng limit, kailangan ko munang i-simplify yung argument na nandun sa loob ni limit. Yung x to the 0, pwede ko muna siyang isulat na 1. Tapos kukunin ko yung limit as x approaches a. Bakit siya magwa 1? Tama ba guys yung theorem? Yung example. Kapag problema ko kasi yung case na n equals 1. Kapag kasi n ay equal kay 1, so meron lang tayong f of x equals x. Tapos ang derivative niya ay 1. Bakit bigla ako nahirapan sa derivatives? Yeah, I probably should have stick to my corrections last semester. I'm just trying to make sense of why is this in the original lecture notes. Do you guys see my dilemma here? Let's see. Okay, totoo naman ito. Okay, as long as, so kasi ang A natin dito ay puro 0, no? Puro 0. 0 yan. So then this is x approaches 0. And then this is a polynomial. So pwede ako mag-plug in. Pero ano mangyayari kapag ka si n ay equal kay, pag si n ay equal kay 1? Kapag ka si n ay equal kay 1, this guy will be x to the 0 lang, constant na 1. So kukuha ko ng limit ni 1 as x approaches 0, dapat equal siya kay 1. Ah. Tama ba guys? Or is it just me not being able to focus? Yeah, probably I should have stick to my corrections last semester. Ginawa ko tong n not equal to 1. Tapos ginawa ko tong 1 kapag ka si n ay equal kay 1. And I think, yeah, I now realize kung bakit pinilit ko yung corrections last semester. Isip ko kanina umaga baka pwede kong hindi na i-correct eh. Pero kailangan ko pa rin pala siyang i-correct, no? And then now the proof here becomes, this is limit ni 1 as, so basically ang proof nandito sa kabila. So ito yung case kapag ka si n ay not equal to 1. This will still hold, but if n is equal to 1, then basically f prime of 0 will be limit ng x minus 0 over x minus 0 as x approaches 0. This would be limit of 1 as x approaches 0 equals siya kay 1. Okay, so end of proof. Pero can you guys make sense of this? No original proof. Hindi ko siya maisip. Bakit siya nandyan? I probably am missing something. Any thoughts, ideas? Or hindi rin kayo makafocus? No idea. So probably I'll stick to my corrections. Yeah. Same tayo. Pero yeah. Pero napag-isipan ko na to last sem. Binago ko rin siya on the spot. Pero kanina umaga nung binabasa ko yung lecture notes, hinahanapan ko ng lusot na hindi na siya i-correct. Pero yeah, ngayon na-realize ko mukhang kailangan ko talaga siyang i-correct. So yeah. But let me think about that more. But I'll edit na yung lecture notes later, and then I'll incorporate these corrections that we have laid down. Okay? Kasi nga hindi siya mag-work kapag si x ay equal kay pag si n ay equal kay 1. Kasi pag n ay equal kay 1, meron ka lang linear function x, ang derivative niya ay 1. Imposible na maging 0 yung limit niya. So hindi na ito mag-hold for all n in n. Kasi nga ang limit ni f prime at 0 when f of x is equal to x ay magiging equal kay 1. Mali yung theorem. So I guess tama yung corrections ko last semester. I should have stick with it. But okay. But I hope that's fine. Medyo ano lang, nagka-problema lang yung gusto natin i-prove, ano? Okay. Now, the promise of remark 4.1 is that this result can be generalized when n takes any real number. Pero kapag ka si n ay kahit anong real number, we might need some advanced techniques. All right? Hindi ko matandaan sa Math 36 kung paano nga ba pinuprove. Halimbawa yung x to the power e. Kasi kung meron kang x to the power e, ang derivative niya ay e x to the power e minus 1 pa rin. All right? Medyo may exceptional case lang dito kapag ka si n ay equal kay what? Kapag ka si n ay equal kay negative 1. Kasi ang derivative ng x to the power negative 1 ay ln lang ng absolute value of x. Okay? But in any case, we can generalize or we can get a general result kapag ka si n ay any real number na. And these are things that you already knew from Math 36. So if I will be asking you to prove something, kaya ako nilagay yung 4.1 dyan eh, hindi nyo na kailangang i-prove by definition. Halimbawa, somewhere in your solution, in a quiz, or in a homework, or in a problem set, kailangan yung derivative ni x to the power pi. Hindi nyo na kailangan bumalik sa definition. Kasi sabihin nyo na lang, sir, sinabi mo na kasi sa remark 4.1, kayang i-generalize yung mga yan. So you can just skip ahead and use that fact, right? And actually, siguro I will allow you to use yung mga derivative formulas, basic derivative formulas that you already know, unless I will specifically tell you to prove them. Okay, so yun yung deal natin dito sa derivatives. Okay, another example to look at how the definition works ay ipakita na hindi differentiable kay zero yung absolute value function. Okay, now I changed the proof nito mula dun sa previous version ng lecture notes kasi doon gumamit siya ng limit from the left and limit from the right. Pero there's a little caveat to using the left-hand limit and the right-hand limit as a criterion for the limit of the function. So kaya ginawa ko para hindi ko na i-discuss yung malalim na technical detail behind that. I used here the equivalence theorem or the characterization theorem for limits insofar as limits of functions are concerned. Okay? So ngayon, ang tiningnan ko ay, una, gusto ko ipakita na hindi siya differentiable kay zero. So gusto ko ipakita na yung f prime of zero is not defined or does not exist. Remember that f prime of zero is basically the derivative of, is basically the limit of the relative quotient or the difference quotient. Okay? Anong ginawa ko rito? May typo pa rin pala dito. This should have been f. So yung f prime of 0 ay limit ng f of x minus f of 0 all over x minus 0 as x approaches 0. Galing lamang yun sa definition. But let's plug in or let's simplify the argument of the limit. F of x is the absolute value of x. Tapos f prime of 0, we plug in 0 here, we get 0. Then the denominator is simply x. So basically, testing the differentiability of f at 0 boils down to checking if this limit exists. Okay? Tapos, feeling ko na kagad na hindi mag-exist yung limit na yan. So gagamitin ko yung sequential criterion for the limits. So magko-consider ako ng dalawang sequences na magko-converge kay 0. Specifically, limit of xn's that is equal to negative 1 over n and the limit ofyn's that are equal to 1 over n. Note na parehas sila ay magko-converge papunta kay 0. Pero pag binuo ko yung sequence of function values, for instance, the absolute value of xn all over xn, pag kinompute ko yan, yung 1 over n kasi sir ay negative yan kasi yung 1 over n ay positive. So yung absolute value ng negative 1 over n will be the negative of 1, the negative of negative 1 over n. Kasi nga nasa absolute value siya. Negative ito, so dapat positive yung absolute value niya. So magiging absolute value niya si 1 over n. Tapos divided by x sub n, but the x sub n is negative 1 over xn. Negative 1 over n. So basically this guy simplifies to this, which is equal to negative 1. So the limit of the function values of the x sub n's is equal to negative 1. However, if you consider the other sequence, yung 1 over n naman, ang absolute value ng 1 over n ay 1 over n pa rin. Tapos ang yn natin ay 1 over n. That simplifies to 1. So yung sequence ng mga function values ng mga yn ay isa lamang constant sequence consisting of 1s. So therefore, the limit of that sequence is equal to 1. Now we have found two sequences that both converge to 0. But the sequence of function values they generate are converging to two different values, namely negative 1 and 1. So therefore, by the sequential criterion, we can say na yung limit ng absolute value of x all over x ay hindi nag-exist. And since this limit doesn't exist, which is basically the definition for the derivative, so we say g prime of 0 does not exist, or in other words, g is not differentiable at 0. Okay, So pinakita lang natin talaga na yung limit ay hindi mag-exist. All right, questions about the proof? Now, looking at example 4.2, we can make our first, actually, in the previous two examples, we can make our first observation or remark. In example 4.1, we have seen a continuous function, x to the power n, that is differentiable at every point in their domain. Okay? Ngunit, yung second example naman, alam natin continuous yan, si absolute value of x. Yung domain niya, which is R, ay walang isolated points, tapos ang graph niya ay V-shape lang, which obviously can be drawn without lifting our pen, so it must be continuous, pero hindi siya differentiable on its domain. Merong isang point of discontinuity, which is basically this point na tinatawag natin na vertex, or ano pa ba ang ibang tawag dyan? Or cusp. Ano? And graphically, ito yung mga characterizations natin para sa differentiable functions. Can anybody recall? Ano nga yung criteria natin para masabi pagtingin sa graph na differentiable lang isang function? Tandaan niyo pa ba? Dahil sinabi natin na yung definition natin ng derivative ay walang pinagkaiba mula din sa Math 36 definition. So any observation that you were able to make during your Math 36 classes ay mag-a-apply pa rin dito. So tandaan niyo pa yung mga requirements, graphical requirements for differentiability. Come on, guys. Alam ko mahirap, pero kailangan nating subukang mag-move forward, ano? Actually, kagabi, sige, habang nag-iisip kayo, ano? Ang gulo, hindi naman magulo, pero aktibong-aktibo yung group chat namin with some faculty members ng Math Division, ano? Kwento-kwentuhan kami ron. At isa sa mga na-bring up na point, motivate yung mga students with especially ngayong araw, especially with the results of the election, kasi the fear of some of us is that paano kaya to? Paano natin mamomotivate yung mga estudyante na mag-aral ng mabuti, tapusin yung kanilang degree, and try to be academics, ano? So, where in fact you could be a senator, you could be president without even having a degree, right? And actually, having a degree, I don't think is a requirement. Hindi talaga yun kailangan. Pero ang doubt ay pwede ka naman pala maging successful without having a degree. Pero yun nga, politics is a different thing. Ano, pag pumunta ka sa corporate world, pag wala kang degree, ay hindi ka nila papansinin unless you are a self-made and already established entrepreneur or a tech guy, ano. So, pero sabi ko naman, pabiro kong sinabi, ano, na mamomotivate yung mga yan kasi wala silang choice. Alright? At saka ito yung ano, motivation na lang para magkaroon sila ng magandang trabaho, either makapag-abroad or yumaman ng mabilis para ma-insulate ang mga sarili nila kung ano man ang mangyayari sa gobyerno. Ano? So, that was meant to be a joke, pero naisip ko parang isang dark comment pala siya, no? So, but anyway, we mere mortals should have appropriate training just to succeed. And I think this is this is one of the hindi naman sure, pero focusing on your education is isa sa mga siguro siya yung may pinakamataas ng probability of success, ano? You can be successful even without your degree, pero mas mababa yung probability. I mean, yeah, I hope I hope you know what I mean. Pero yeah. So ano, naisip nyo na? Ano nga yung requirements natin para maging differentiable by looking at the graph? Okay, David Benedict is yeah, partly correct na smooth yung curve para magkaroon ka ng derivative at a point. Yes, that's the usual characterization. Pero what is smooth? Ano yung konsepto ng pagiging smooth? Now, sa Math 36, siguro ang konsepto natin ng pagiging smooth ng isang curve ay yung hindi pagkakaroon ng sudden turns. Halimbawa, itong absolute value function, sabihin natin, hindi yan smooth kasi meron niyang sudden turn dito sa vertex. At yung point of the sudden turn, siya yung point of non-differentiability. Now, another is the existence of cusps. All right, na can also be treated as a sudden turn. So, isa rin yung posibilidad. At saka yung mga points of discontinuity. All right, though spoiler alert, mamaya pa pala dapat yon. Kasi kung discontinuous ng isang function, it doesn't make sense na magiging differentiable pa siya. Coming from the smoothness requirement, ano? So, yun yung gusto kong i-prove ng susunod. Na pwede nating isang maging criterion aside from pagiging smooth ng graph, ay yung pagiging continuous ng graph. Okay? But first thing, we already know that a continuous function is not necessarily continuous, but now we will prove that a continuous, we have seen that a continuous function is not necessarily differentiable, but a differentiable function is necessarily continuous. Sana tama yung naisip ko. Yeah, that is exactly theorem 4.1. Okay? So, ano sabi ng theorem 4.1? Kapag meron kang isang function, f na differentiable sa number a, then automatic na si f ay continuous sa number a. So, yan yung gusto nating i-prove. Okay, actually the proof is quite easy, though yung main point niya ay medyo may pagka-creative, right? So there's the goal is to write this guy into a nice form that will allow us to conclude the continuity of the function, the continuity of the function f, right, or the function g na ginamit dito. Now, let's see. So, ang assumption natin dito ay differentiable yung function g kay number a. So, ibig sabihin g prime or this limit exists. Alright? So, yun yung kailangan lamang para maging differentiable. And as I have mentioned, I should be able to find a nice form for this guy para makonclude ko yung continuity ng function g. Okay? Now, apparently, the nice way to put it is to look at the limit of g of x minus g of a. Right? And you will see later why. Okay. Now, maganda siyang gamitin because this limit actually can be written as this guy. Limit ng g of x minus g of a. So this was copied over, but I multiplied and divided by x minus a at the same time. Right? So kasi yung x minus a dyan, makakancel lang naman. So makatitira yung g of x minus g of a. And dividing by x minus a is fine because you might be thinking, well, hold on, sir. Why are you dividing by x minus a? Kasi baka naman si x minus a ay equal kay 0, right? But note that the key thing here is that we're looking at the limit as x approaches a. So we don't care about the behavior of the argument of the limit sa eksaktong x equals a. What we are interested in is what happens when x approaches a. So si x paparating pa lang kay a. So ibig sabihin yung x minus a, hindi pa yan magze-0. Kasi palapit pa nga lang si x papunta kay a. So this could be an infinitesimal number, but it is not exactly 0. And division by a very small number is allowed. Ang hindi lang pwede ay mag-divide tayo ng eksaktong equal kay 0. Okay? So that's why valid na mag-divide ng x minus a. And why did I do that? I did that kasi, yun yung nasa premise. Alam ko din nag-exist itong derivative na to. Itong limit na to. So dahil nag-exist yung limit na yan, gamitin ko siya rito. Nag-start ako sa g of x minus g of a para maging kamukha siya nung nandun sa assumption na alam ko na nag-exist as a limit. Mag-divide ako ng x minus a, which is fine as I've explained earlier. Tapos to maintain the equality of this guy with this guy, mag-multiply lang ako pabalik ng x minus a. Okay? And now, I know that this has a limit. This limit exists, or its limit exists. This guy is a linear function, so meron din siyang limit. So limit ng product ay equal lamang sa product ng limits. This limit is exactly g prime of a. The limit of x minus a as x approaches a is 0. Okay, so the limit of the product is equal to 0. the product of their limits. So we are here we have seen that limit of g of x minus g of a ay equal kay 0. Tapos alam ko na yung limit ng g of a ay nag-exist kasi si g of a ay constant lamang. So ang limit ng constant ay nag-exist and it is equal to itself. So this exists. The limit of the difference exists. So that forces the limit of the minuend to exist. Kasi kung hindi mag-exist itong limit na to, pero nag-exist itong limit na to, then dapat hindi na mag-exist yung limit ng difference. So kaya kailangan talaga mag-exist yung limit ni g of x. And actually the limit of g of x doesn't just exist, it is equal to g of a. And what do we have here? We have seen that the limit of g as x approaches a is equal to the function value of a, which is the very definition of being continuous. Okay, so we started with the assumption that g is differentiable at a and ended up with a conclusion that g is continuous at a. So ibig sabihin, indeed, differentiability implies continuity. Okay, and then if you get the converse of this statement, ano yung converse ito? Yung converse ay negation nito implies negation ng premise. So we'll have f is not continuous implies f is not differentiable. Kaya sabi ko kanina, pwede nating idagdag dun sa list natin ng mga criteria para sa graph ng isang function para siya ay maging continuous. Dapat siya ay para siya ay maging differentiable. So dapat continuous muna yung function. So kasi pag discontinuous yung function, automatic na siya ay hindi na posibleng maging differentiable. Pero kung siya ay continuous, still there is a chance that it might not be differentiable. All right? Okay, is that good? But that shouldn't be a surprise to you guys kasi nakita niyo na to mula sa Math 36, ano? So and then we'll have theorem 4.2, your usual derivative formulas. So derivative of the sum is the sum of the derivatives. The derivative of a scalar product is the scalar product of the derivative. Medyo nagkaiba nga lang sa derivative ng product at derivative ng quotient because we have what we call the product and the quotient rules. Ano? So ito yung hindi straightforward, yung relation between the derivative of the components with the derivative of the result of the operations. Okay. Now, the proofs that you have seen in Math 36 can be adopted for these proofs. Okay. So, pwede niyong balikan. Ang sinama ko na lang dito ay yung proof ng part C, which is the product rule. And again, this entailed a clever manipulation of the expression in the definition. Because remember, fg prime of A is equal to the limit of fg of A, fg of x, minus fg of A all over x minus A as x approaches A, right? So to show to get a formula for this guy, kailangan natin ng clever way of manipulating the argument of the limit. And the lecture notes reveal that, okay, ito yung clever way. Mag-add and subtract tayo ng f of x times g of a. Because if we do that, then we can split the entire expression into two groups. The first group consisting of the first two terms in the numerator. So we'll have f of x, g of x minus f of x, g of a. Oops, they share the common factor f of x. So factor f of x out and then hope that the remaining factor has a good form. Okay. Tapos doon naman sa kabila, i-group ko tong dalawa na to. What I can factor out here would be the g of a's. So labas ko yung g of a. And then I'm hoping that this guy will have a nice form. But actually, it's apparent that they do have nice forms. Kasi ito mismo, yung limit na nandun sa definition ng derivative. Tapos ito rin yung nandun sa limit na nasa definition ng derivative. So if we take the limit of both sides, as x approaches a, copy-paste dyan, copy-paste dito, tapos copy-paste dyan. So ibig sabihin, limit ng product, okay? Pero si f of x ay ano bang condition kay f? Alam na natin si f ay differentiable, so siya ay continuous. So may limit si f of x as x approaches a. May limit din ito as x approaches a. So ibig sabihin yung limit ng product ay product ng limits. The limit of f of x is equal to f of a. Kasi si f ay assumed to be differentiable. Dahil si f ay differentiable by theorem 4.1, f is continuous. Dahil si f ay continuous, ang limit ng f of x rito, f of a yan. So merong mga limit na to sa unahan. Ha? So yung limit na yun ay equal kay f of a times limit nitong quotient na to, but that is just g prime of a by definition, plus g of a times the limit of this guy as x approaches a, but this is only what? That is just f prime of a. So that ends the proof, okay? So nothing fancy about the proof. It's just that we need this clever expansion of the expression inside the limit. We can try and any lecture notes yung hint para dun sa part D. Okay? So I'll give you as reading assignment na lang yung part. Titingnan nyo kung paano or ano yung naging clever expansion para dito sa expression na to na mapupunta dun sa loob ng limit dun sa definition ng derivative. Okay, guys? Andyan pa ba kayo?
Dito pa po, sir.
Okay, thank you. Okay, so siguro this could be our last. Sige, probably this could be our last result for the day. And then siguro sa Wednesday, sa Thursday na yung natitira. Tingnan ko kaya ko siya sa Thursday. Interior, Darboux, mean value theorem. Yeah, 4 na results. 5 L'Hopital's. Actually, marami pa pala, no? Sige, let's see. Let's see how long will it take us for doing theorem 4.3 bago tayo pumunta. Siguro kung mabilis natin ito matatapos, pwede tayong pumunta dun sa susunod na result, which is I think the interior maximum theorem. Okay. But essentially, let's start with the chain rule for the derivatives. Okay. Now, actually, the chain rule for derivatives, kailangan lang din natin ng isang clever way. Pagsusulat nung limit na nandun sa definition ng derivative. But let's first see what are the details para ma-define yung chain rule para sa derivatives. So una, kailangan natin ng dalawang functions which have domains A and B respectively. The condition is that the f bracket A, the image of the set A under the function f, ay subset ni B. Para lahat ng result na manggagaling kay function f ay nandun, ay pwede natin gawing input kay G. Kaya kailangan natin ito so that every result after evaluating the function f ay pwede nating ipasok na pang-evaluate kay G. Okay? So yun yung sinabi ko rito such that G circle f is well defined. Now here our assumption is that f is differentiable at number a and G is differentiable at f of a. Then the conclusion is that G circle f is differentiable at a with the following formula. Pero alam niyo na to, ito yung chain rule na natutunan natin sa Math 36. Tingnan natin paano ginawa yung proof. Okay, first, we expanded this guy in terms of the definition ng derivative. So G circle f prime of a is basically the limit of G prime of G circle f of x. Pero yung G circle f of x ay equal lamang sa G of f of x by definition and composition. Similar thing happened for G circle f of a. It's just G of f of a all over x minus a. And then our goal is to show that this limit is equal to this guy. Okay? Pero medyo mahirap ipakita straightforward na ito ay magiging equal dito. So kailangan nating i-manipulate ng konti itong expression na nandito. Okay, para makita natin saan mga magiging equal yung limit ngayon. Now, in order for us to do that, kailangan kong tingnan ano ba yung mga assumptions na alam natin mula dun sa problem. Well, one of the assumptions here is that G is differentiable at f of a. Kasi mukhang kailangan kong tingnan ano yung itsura ng G prime of f of a. Kasi medyo yun yung maglalaro dito sa loob ng limit definition. So let's look at what happens. So G prime of f of a, we know this will exist because we know that G is differentiable at f of a by assumption. Tapos isusulat ko lang ito using the limit definition. Okay? Now, medyo may pinagkaiba lang. Remember, this should have been x approaches a. Pero dahil ang input natin sa loob ni G prime ay si f of a, so we are taking the limit of a dummy variable as it approaches f of a. So ginawa ko lang y yung dummy variable para si y ay palapit ng palapit kay f of a. So in that language, so we'll have g of y minus g of whatever is inside the derivative. So we got f of a all over, instead of an x here kasi binago ko nga yung variable, y minus f of a. So basically, ito lang yung definition ng derivative applied to g prime of f of a. Tapos kailangan ko ngayong malaman paano ko ito magagamit para ma-evaluate itong limit na to. Alright? So medyo, saan lang ba ito nagkatalo-talo? Mukhang nagkatalo lang sa denominator. Because if you think of y equals f of x, so virtually, this is g of y minus g of the function value at a minus, yun nga lang, dapat ito ay naging, ito ay x, pero yung nasa ilalim, y naman, yung nandun sa denominator. So it would have been easier if this happened to be f of x minus a, ano, kasi yun lamang yung y minus a, straightforward na definition ng derivative. Pero hindi ganun yung nangyari. X minus a yung denominator dito, tapos dito yung denominator naman y minus f of a. So we need to do a little bit of a manipulation here. Okay? And for the sake of what will follow later, dapat pala daw nating isulat or i-define itong auxiliary function v na ito. Okay? So siguro ngayon ipaklaro kung bakit natin kailangang isulat or bakit natin kailangang i-consider si v. Pero si v sort of siya lang yung parang differential. The differential function. Pero kakailanganin ko kasi yung itsura nito later para ma-prove yung or para ma-compute o ma-simplify ito. Alright? So let's just analyze this. So define ko lang si v na parang binura ko lang tong limit tapos sinranspose ko yung g prime dun sa kabila. Kaya ko ito nakuha. Okay? And so if you take the limit of vy, ito ay magiging equal lamang kay 0. Kasi nga essentially, ano lang to, ito nilipat ko lang sa kabila as a negative g prime of f of a. So ito ay naging equal 0 na lang. Tapos tinanggal ko yung limit. Siya yung function v. Pero if I restore the limit, so if I take the limit of the function v as y approaches f of a, I'll get 0. Alright? Kasi nga ito si v, kunin mo yung limit as y approaches f of a, ito ay magiging eksaktong ito ay siya pa rin, so their difference would be equal to 0. Okay? Medyo may problema lang kay little v. Bakit hindi ko siya pwedeng gamitin? Kasi si little v ay undefined kapag si y ay naging equal kay f. Remember, posible nag-exist yung limit niyan, pero hindi nag-exist yung function value. And in that case, that is true when y equals f of a. When y is equal to f of a, the denominator here is exactly 0, and division of 0 is not allowed. Pero alam naman natin, yung limit nito as y approaches f of a ay equal kay 0 dun in the limit, right? So, kaya pwede ko siyang gawing continuous pa rin, kaya lang kailangan kong i-define si v this way. I-purpose ako dapat na magkaroon siya ng function value kay f of a. And the best choice for the function value na i-assign natin kay f of a ay kung ano yung limit as x approaches f of a. So that in that case, this function d will be continuous. So in other words, the limit of d of y is still equal as y approaches f of a is still equal to 0. Okay? Kasi ito lang naman yung titingnan natin when we are taking the limit as y approaches f of a. All right? So equal siya kay 0. Hindi tayo nagma-matter kung ano yung function value. Pero yung d of f of a ay equal kay 0 by the red definition that we made. So essentially here, we have a function d that is continuous, or that was purposely designed to be continuous. Okay? Okay, and then if that's the case, then tingnan natin ano yung mangyayari kapag ka naman si y ay hindi equal kay f of a. Well, if you will look at g of y minus g of f of a, which is basically the numerator here, okay? So parang mangyayari lang, ito ay pwede kong isulat as pwede itong sulat na d of y equals g of y minus g of f of a all over y minus f of a minus g prime of f of a. Gagawin nyo lang, okay, transpose ko to pabalik doon. So magkakaroon ako ng g prime of f of a plus, so this should have been a plus d of y. Kalimutan ko pala ito correct kanina. Tapos you multiply both sides of by y minus f of a. So we get this isolated on the left side. Okay? Tapos dahil alam ko na to, okay. Alam ko na yung itsura nito. Ang gagawin ko ngayon, i-divide ko to by x minus a. Because remember, that was the problem that I had. I cannot use this or I cannot directly take advantage of this para ma-compute na to. Pero ngayon, alam ko na ano yung itsura ni g of y minus g of f of a. So magiging kamukha na siya nito. All it takes is division by x minus a. So yun yung ginawa ko sa step na to. Dinivide ko both sides by x minus a. Tapos ito, i-divide ko by x minus a. Pero yung x minus a na denominator, ipapasa ko na siya dito kay y minus f of a. And then I will replace y by f of x. So essentially, what we have is this guy being equal to this guy. And then ngayon, kukunin ko na yung limit. Kasi remember, that's our entire goal. Our goal is to take the limit of this guy as x approaches a. Now we have an expansion for this guy. So all it takes is to find the limit as x approaches a. Tapos kukunin ko yung limit nito as x approaches a. Now as x approaches a, this guy will approach g prime of f of a because this guy is a constant. The limit of a constant as x approaches any number is equal to the constant itself. So kaya natira siya dyan. Tapos ang limit naman ng d as x approaches a ay equal kay 0. Because as x approaches a, this will be a d of f of a, but f of a is equal to 0. F of a, d of f of a is equal to 0. So this guy goes to 0. Kaya naging g prime of f of a na lamang yung contributor from the first factor. And then the limit of the second factor is very familiar. That is essentially the derivative of f. So ito, limit nito ay equal lamang kay f prime of a. And then we got this formula. And we're done because we have shown that the limit of this guy, which we already noted to be equal to g circle f prime of a, ay equal kay g prime of f of a times f prime of a. And that's the chain rule. Okay. Now we have this various rules for differentiation. So ito na yung gamitin nyo para if ever you encounter a problem in the homework or in the problem set, no? And then if it is just a simple function like polynomials, trigonometric functions, logarithmic, exponential, hyperbolic, inverse hyperbolic, so pwede nyo nang gamitin yung mga derivative theorems or derivative formulas na natutunan natin mula sa Math 36. Okay? Then siguro last na lang, if okay pa kayo dyan, i-discuss natin yung interior extremum theorem. Okay? Itong interior extremum theorem, kahit fancy sounding yung pangalan niya, pero nakita na natin to before mula sa Math 36, and actually that is the sufficient condition. Actually, sufficient ba or necessary? Ito yung necessary condition na ginamit natin sa optimization natin ng Math36. Kasi sinasabi ng interior extremum theorem ay kung si f ay nag-attain ng maximum o minimum point or minimum value kay x sub 0, then dapat yung derivative ay equal kay 0 kay x sub 0. So basically, it is telling us that the derivative at the maximum point or and at the minimum point ay laging equal kay 0. Tapos kung matatandaan nyo, ito yung ginamit natin dati sa Math36 kasi alam natin necessary na kung meron ka maximum or minimum, dapat ang derivative ay equal kay 0. So ang ginawa natin dun sa ating Math36, okay, para makita yung mga candidates, para magbigay sa atin ng maximum o minimum, in-compute natin yung derivative, in-equate natin kay 0, kinuha natin ano yung mga excess na nagpapa-0 dun sa derivative. Sila yung candidates para magbigay ng relative extrema. Okay? So ito yung basis bakit natin to pwedeng gawin sa Math36. Okay? So let's look at the proof. The proof is not that difficult. Okay? So, all right. So assumption, nagma-maximum or nagmi-minimum yung function f kay x sub 0. So it's either x comma f x sub 0 comma f of x sub 0 is either a maximum or a minimum of the function f, or more particularly it could be a relative maximum or a relative minimum. Okay, so consider lang natin, okay, si x sub 0 yung minimizer or maximizer ni x sub 0 ni f sa buong interval AB. And then, dahil si x sub 0 ay element ni AB, automatic si x sub 0 limit point na yan ni AB. Right? Kasi kahit anong element ng isang open interval ay limit point noong interval na yon. Okay? So since this is a limit point, we can construct two sequences within the interval AB such that x sub n converges to x sub 0 and the same thing happens for y sub n. So pareha sila nagko-converge kay x sub 0. Pero ang gusto ko yung mangyari, yung mga x sub n's dapat laging nasa kaliwa ni x sub 0 at si yn laging nasa kanan ni y sub 0. Yun yung sinasabi ng inequality na yan. Well, this is possible kasi nga si x sub 0 ay element ng open interval AB. So, kayang-kaya nating magbuo ng isang sequence ng mga elements ng open interval AB na nanggagaling sa kaliwa ni x sub 0 at nanggagaling sa kanan ni x sub 0 na parehas nagko-converge kay x sub 0. Kasi ang kagandahan nito, si x sub 0 ay parehas left limit point at saka right limit point. So that's why this the construction of these two sequences actually is quite elementary. Right? Or we know that it is indeed possible to construct such two sequences. Tapos i-assume natin, kunwari lang, for this particular case, na si f of x sub 0 ay isang maximum value. Yung proof para kung si f of x sub 0 ay minimum value will be very similar. So ipapakita ko na lang dito ay kapag siya ay maximum value. Kung si f of x sub 0 ay ang pinakamalaki na function value sa buong interval AB, then ibig sabihin, ang f of xn minus f of x sub 0 ay laging negative. Or actually, ay laging non-positive. And the same thing goes for f of yn minus f of x sub 0. Okay? Tapos ano yung mangyari? Gusto ko ipakita na ang derivative ay equal kay 0. Now, the idea here is, I wanna show na isa lang yung posible maging value ni f prime of x sub 0. And how will we do that? Well, gagamitin ko yung continuity requirement. Ano? So, si f ay differentiable, so dapat yung limit na to ay mag-exist. Okay? As x approaches x sub 0. Pero gagamitin ko yung sequential criterion. But keeping in mind, dapat nag-exist yung limit na to. So that means if this exists, then this could be f prime of x sub 0. Pero by the sequential criterion para sa limit ng isang function, kung ano ang limit ng function na to, siya din yung limit ng sequence ng function values na nagko-converge kay x sub n. Okay? So, yung mga f of x, papalitan ko lang ng f of x sub n, kukunin ko yung sequence na to, titingnan ko saan nagko-converge yung sequence na yan. Okay? Now, what do I know about this guy? I know this will exist because this is necessarily equal to this guy. So, dahil nag-exist siya, tingnan natin. Oh, tingnan mo yung numerator. Yung numerator ay f of x n minus f of x sub 0. But we said that f of x sub 0 is the maximum. So, the numerator is always less than or equal to 0. Pero yung denominator, ano masasabi natin sa denominator na xn minus x sub 0? Yung mga xn ay nanggagaling mula sa kaliwa ni x sub 0. Okay? So that means this guy is also negative, or actually is also less than or equal to 0. So something less than or equal to 0 divided by something less than or equal to 0, we get a non-negative answer. That would be greater than or equal to 0. Pero yung pakabila naman, yung f of y, n naman yung titingnan natin. Okay? Equal din yung kay f prime of x sub 0 kasi sabi ng sequential criterion, kapag ka nag-exist yung limit, yun din yung limit ng kahit anong sequence sa mga function values as long as yung domain elements ay nagko-converge doon sa limit point x sub 0. So that means this limit, which is equal to f prime of x sub 0, must be equal to the limit of the sequence of function values. In particular, it should be equal to f of yn minus f of x sub 0 all over, this should be y sub n minus x sub 0. And we have noted that since the numerator, the numerator will always be less than or equal to 0 because this guy is not less than f of yn. So kaya ito alam ko ay less than or equal to 0. Tapos yung mga yns nanggagaling siya sa kanan ni x sub 0. So ibig sabihin ito ay non-negative. Right? So we have a non-positive numerator and a non-negative denominator. So the fraction will be negative. So what are we saying here? We're saying that f prime of x sub 0 is always greater than or equal to 0, but at the same time, f prime of x sub 0 must be less than or equal to 0. And that there's only one way that we can reconcile this inequality, and that is the case that f prime of x sub 0 is equal to 0. And that is, and dapat mapuwersa yon. Kasi alam na natin na nag-exist si f prime of x sub 0 in the first place. So we are forced to conclude na okay, si f prime of x sub 0 ay equal lamang kay 0. So ibig sabihin, ang tangent line lagi sa isang relative maximum at saka sa isang relative minimum ay laging horizontal lamang. Okay, but again, this is what we have already learned from Math 36. Then I think we can stop here, saktong-sakto 12:50, and then hopefully next time we can finish module number, the lecture notes for Unit 4, and more importantly, hopefully, maayos na tayo at makafocus na tayo sa Thursday. Ano? Okay, any questions or clarifications? Okay, so kung wala naman, thank you guys for coming today. I know it's difficult to come today, but I really appreciate your attendance. And then let's just meet na lang uli on Thursday, hopefully with us being in better spirits, okay? Enjoy the rest of the day, guys, and keep safe. Bye-bye.
Thank you, sir.
All right.